Welcome to Metal Casting Lecture Series by Professor Joyjeet Ghose. This is the sixth lecture of a series of lectures. This lecture will be on sand casting molding methods. He will be discussing about various types of molding practices: squeeze molding machine, jolt molding machine, jolt squeeze molding machine and sand slinger machine. So, do not miss and watch the full video. For the next video in the lecture series, please click the suggested video link above. You may also click on the playlist at end of the video to access all the videos. Please subscribe this channel and yes, do not forget to like and share. Also click on the bell icon to receive instant information of new videos uploaded. Thank you.
Hello friends, welcome to this lecture 6 of a series of lectures on metal casting. In this lecture, we will be discussing about molding processes. Molding processes can be carried out in various ways. It can be bench molding, where we carry out molding of small jobs and the whole operation is carried out on a bench of convenient height to the foundryman. Then we have floor molding. In floor molding, we carry out molding of medium to large size jobs, and it is carried out in the floor itself, normally made of sand. And then we have peat molding, where we make a pit in the floor and the pit is lined up with fire bricks, and we carry out the molding in the pit itself. That is mainly for large casting. We use cranes for lifting the molds. That is called pit molding, not listed out here. Then we have the machine molding, where we employ a machine called squeeze machine or jolt machine or jolt squeeze machine, or you can say slinger machine, sand slinger machine. So those machines can also be employed for molding processes. So floor molding, as I have said, is used for medium size casting. It is carried out on the floor. In this molding, the floor acts as a drag, and the ramming is carried out in the floor itself, and it is time consuming. It requires labor and mainly used for green sand and dry sand molding. Then we have peat molding. It is used for large casting manufacturing. Peat is dug on the floor of the foundry with a bed of charcoal placed at the bottom of the pit to help the escape of gases, and carry out the molding process. So this is peat molding. And then we have molding machines. So in molding machine, hand ramming, we already know how to carry out hand ramming. We have squeezing machines. In squeezing machines, there is a platform. The molding board is on the platform, and we place the pattern and then the flask on the platform, and then we pour in the required amount of sand, and from the top side, the entire sand is squeezed. The molding force is given by the formula P into, where P is the pressure of the squeeze cylinder, and D is the diameter of the piston diameter, and W is the weight of the flask pattern and the sand, both together. So this is the molding force. So when you apply force or pressure from the top, what happens? The area at the bottom or near the piston has more density, but near the pattern the density is less. That creates a problem. So therefore, another technique is used called jolt molding machine. In jolt molding machine, the process is same as squeeze molding. Only thing is that the lower platform is slightly raised and then released. So when it raised and released, so what happens? The sand falls in the flask, and therefore it becomes compacted inside the flask. Now obviously, if you lift and give a jolt, then the area near the bottom, that is near the pattern, will have more density, whereas on the top side or facing upwards, the side facing upwards, will have lesser density. So therefore, to overcome that, we not only give jolt, and from the top we give a squeeze. So that is called jolt squeeze machine. So in this type of molding processes, we normally use cope and drag pattern or match plate patterns. So this is how this is normally pneumatically operated air cylinder. You can see it will lift up, the anvil will lift up and then drop it slightly, only slightly, very small height, that it gives a jolt, and the sand here will have higher density due to this jolt, and this here it will have lesser density. So therefore we give a squeeze also, not only jolting, we give a squeeze. So density here is high, also the density here will be higher. So that gives a good mold. This is how actually a jolt squeeze or machine looks like. You can see the air cylinder here, and it is lifted and dropped, and this is the squeezer. There's another piston here which will do the squeezing operation. Then we have a sand slinger. In sand slinger, what we do is that basically in mechanized foundry where large number of molds are made, so there is a conveyor which carries the sand, and there is a bucket. It looks like a Pelton wheel bucket. The bucket picks up the sand and throws it inside the mold. So by the impact of this throw, the sand will be tightly packed near the pattern. So the density is fairly uniform. So such type of molding is called sand slinging process. So this is how it operates actually. So you can see the funnel here gives the sand, and this bucket throws the sand in the mold. So actually normally there is a conveyor which carries the mold. Number of molds are filled very quickly by sand slinging process. So in this lecture we will discuss up to this. In the next lecture we will be discussing about various types of molding sand test. Thank you for watching this video.